breaking NBAD and UEBA and two other new acronyms I've never heard of until today. So thank you.
Thanks. All right. So this deck, I gave a 2013 talk here at GrrCON on the benefits of network behavioral anomaly detection. And we're going to revisit. I really wanted to give this talk for the better part of 5 years on how the importance of logging correctly, logging in a way that holds up in court, a way that cannot be broken. A little bit about myself. I was in the U.S. Navy for 10 years. The first part of that, I was an aviation mechanic. I worked on F-18 Hornets. After 9/11, I was detailed to the Naval Postgraduate School in Monterey, California, where we got to spin up the School of Route. So captured the flag team. We won so many times at DEF CON, we're not allowed to compete anymore. But that was fun. Worked in the Navy up until 2005, left and did consulting work with DoD and State Department on workflow, sharing information, sort of security operations pieces. And figuring out what works, what doesn't work. I worked for them for World Test Center, doing product reviews. They would ship me the stuff, I'd see what worked. Those would get written up in reviews up until journalism died in 2008 and the test center shut down. Went to work for a company called Landcope in 2012. We had done initial NBAD research with Georgia Tech. That research became a product called StealthWatch, which is now owned by Cisco. That wrapped me into Cisco. And I started a company called Witfu in 2016. And we do big data security stuff. So real quick, we're going to go over some basics, define some terms. What is NBAD? What is UBA? Then we're going to roll right into how to poison the data, why we want to poison the data, and the actual techniques for doing that. Then we can go into Q&A. So real quick, Dr. Dorothy Denning wrote a paper in 1986 called, what is it? I should have written down, Intrusion Detection Expert Systems. And in that paper at the War College, she wrote out these 3 different ways that we detect attacks. And these have sort of held up over the years, though marketing buzzwords have changed. Signature-based detection is inspecting the object. So I look in the water, there's something floating in the water, I'm not going to ingest the object. So in network security, that's inspecting the packet, inspecting the file. There's something known bad in the characteristic of that packet or that file. Behavioral detection is you observe the subject after it ingests the packet, the file, for a known bad behavior, like encrypting the disk, deleting files, scanning the network, those kind of things. So you don't know that the object's bad at the time, but you know that the following behaviors triggered by it are bad. And then anomaly detection is looking at every possible behavior and then categorizing it as good or bad. And so something that's anomalous is just uncategorized. It's not normal. And so the way that those things spin out is signatures are generated by behavioral detection. So net new signatures are generally caught by things like sandboxing and other behaviors. You say, okay, here's a new piece of malware. We've detected it. You reverse engineer it and create a signature for it. And anomaly-based detection is how we generate behavioral checks, like what are the new behaviors we should look for in the wild. And they have different use cases, things that are useful. Signature-based, of course, has the benefit of being the most accurate, the least in false positives, because you know exactly what it is, why it was created, and the implication of it. When we look at anomaly detection, or sometimes we're talking about machine learning, the basic framework is you're going to establish a baseline of what's normal. So some type of mathematical calculation, how many times does the user log in a 24-hour period? And then you're going to establish these baselines, and then a detection is going to be a mathematical violation. So if it's 2x or a standard deviation away from the baseline. One thing to look at in baselining is, do you baseline the entity, the user, the host, those types of things, or do you baseline the set of things, like the guest wireless machines as a set, the domain controllers as a set, that type of thing, or do you look at them individually? It takes time to build a baseline, and obviously all time is not the same. Midnight's different than the morning and that type of thing. And when we talk about supervised machine learning, it's really taking a set of variables and saying we're going to study this set of numbers and look for changes in that. Unsupervised is computer, you discover what the variables are and look for deviations there. So NBAD was a term that came out. Gartner coined it in 2001 when IDS was still coming out back in the days, early days of Snort with Marty and those things were coming out. NBAD was network behavioral anomaly detection. And since it counts things, it's counting how many packets are going from these types of hosts to these types of hosts, or how many packets have SYN flags in them versus SYNACs and that type of thing. NetFlow became a really good source of data because you're not really inspecting what's inside of the packet. You don't care what is in the packet, you care about how many of those types of packets you have. And so NetFlow is a lot cheaper, especially in the early 2000s, to monitor particularly east-west traffic. You could look in the core deeper. Now you can even get down the access layer. But it's very quantity or metric centric. It's not looking for a signature to trigger. And so sometimes you'll see NetFlow tools connected to network behavioral anomaly detection. But there's a lot of tools that do these things. This is a list from Gartner that commercial tools that do network behavioral anomaly detection, Qflow from IBM and the rest. So when you start looking at NBAD, you're looking at service type, threshold changes. So computers are always only using HTTP type of protocols and email, and all of a sudden it's into Tor, right? There's a shift in the type of consumption happening. Actually, that's type anomaly. Traffic anomaly is the amount of data. This host normally consumes a gig of traffic in a day. Today it has consumed a petabyte of traffic. Those allow you to do things like data hoarding. Data hoarding would be a host on the network that's consuming too much information from internal resources. Data disclosure or exfiltration is a machine that's pushing too much data out of the network. And those are really cool counters, because if you're distributing it over something like a BitTorrent or another distributed type of protocol, you can't just count how many bytes are going to a given host. You have to count how many have left a given host to all of the destinations and do math against that. So when we first started doing security operations, those of us who have been doing it for a while, we had alarm rows, right? You would have an IDS or a firewall or something that would generate an alarm, and there would be way too many of them. And you would prioritize and triage those things. What's the higher priority? What are the counts? But it was based on alarms. And then as security operations evolved, we started looking at host-centric based detection, meaning let's not look at the alarms, let's look at how many alarms each host has, and then investigate the host, the computers. And then user-based analysis started later, to where you took, okay, here's all the hosts that the users are on, and here's all the alarms that are associated with those hosts, so we can draw a big circle around that and investigate that as a unit of work, which reduces the units that need to be investigated. They also look for, more advanced UBA is looking for deviations on user behavior. When does a user log in? What type of services does a user consume? Those types of things. Long list of these things, and this was from eSecurity Planet. Oh, and if you guys want this deck, you can get it either, if you go to charlesherring.com, they'll 301 you over to my LinkedIn profile, or it's on the WITFU blog, this whole deck. So there's a few things on UBA. Some common types of detections are magic carpet. So someone just logged in Grand Rapids, and then 30 seconds later they logged in from Tehran. They can't move that fast. So how did that happen? So magic carpet detection. Time of day anomalies. Someone that's always at work during the daytime hours is now after hours on the weekend. The types of hosts that they're accessing. This administrator shouldn't be accessing source code or blueprints or that type of thing. So that's the background on the definitions. Got that out of the way pretty quick. Now let's talk about the fun stuff. Let's go into how to do some data poisoning. So a few things to point out in data poisoning. There's some types of poisoning. So mass implication means, sure, I'm doing something, but I'm going to create a scenario that makes it look like everybody's doing it. So if I'm scanning the network, what if it looks like every host is scanning the network? Then how do you investigate that? It's mass implication. Baseline boiling is fun but exhausting. Because baselines are built over time, you can just start generating traffic that increases the counters that generate the baselines. So if you're counting how much data a group of hosts consumes in a day, well, just generate a little bit more on day one, then generate a little bit more on day two. And those baselines will slowly start to boil or grow, and then you can do whatever the hell you want. These are really good on time of day attacks. Just give one attack that's at the edge of the current window, so at the end of the days, and then a little bit later, then a little bit later, and a little bit later. And then baselines become useless because everybody's logging in all the time from everywhere. Attack masking, I'll show you an example of this is when I do a SYN scan and tools that are like network tools that are checking a SYN, but there was no SYN ACK coming back, so they can detect recon off of TCP headers. What if I just generated a record that says there was a SYN ACK, right? So I SYN, nothing comes back. I generate a record that says SYN ACK. It looks like it was a bidirectional a bidirectional connection when it was really not. So it's changing the behavior or hiding the behavior. There's a couple ways of accomplishing this or transporting it. One is log spoofing, which means as the attacker, we're going to go through some scenarios where I just generate a fake log and I ship it to the thing that analyzes logs, and it doesn't know what to do with that log. So it's that way. The other is having the infrastructure generate the logs for us. So we don't, so for instance, in the case of a net flow generation, if I'm connected to a switch and it observes my fake traffic, it's going to generate telemetry or records about that fake traffic and then forward it on to the processing source. And so the places that we'll do this will either be on a computer, a machine, a VM, a Docker container. You'll see a lot of that. So something we control, or it'll be generated by a networking device. So this is from my tool. This is a representation. The attack on, what's that? That's your left. I don't do directions. On your left is an attack that the University of Chicago let me share, but it was a data exfiltration attack from left to right as different parts of the kill chain getting strung together. But the goal, that's what we want in UEBA, network behavioral anomaly detection, advanced analytics. You want to draw a clear picture that tells the security team, here's what's going on, and then they can respond to that. What we're going to try to do today is either the top thing, which is the ninja, right? You're invisible, you mask your attack and they never see any of it. Or what we're going to do more of today is cover it in noise. There's just so much noise that they can't figure out where your attack is. Your attack is hidden somewhere in what we call a clouded death. So the fixes for this, I'll start and end with this on the before we do the attacks. One of the core problems we have in the craft is IT really is an extension of manufacturing as a craft. When we talk about a craft, it's things that are being created, spreadsheets, Word documents, websites. It's things that are being generated, units, widgets that are being shipped, stored, that type of thing. So most of what we learned about IT we took from manufacturing. But cybersecurity operations has nothing to do with manufacturing. It's an extension of law enforcement. It's an extension of stopping infraction of law and violation of policy. But we don't work that way, so it's because we've extended from manufacturing instead of law enforcement, we've picked up some bad habits. But one of the core things as a law enforcement officer is you understand the importance of non-repudiation, that the evidence you collect has to be viable evidence will hold up in court. But when we're doing security operations, and as I work with different organizations on this, they just believe everything. And so if you're I was able to give this talk at DEF CON to the red team in the red team village, that this is a great way to blow up the whole pen test. Do whatever you want. Then the security team's trying to respond to all this noise you just generated, and they can't parse what's real and what's not real. And it's because you can't trust your evidence. And so the first thing I just want to point out here is, how do you get to a place where you can trust your evidence? The best way that that exists, at least in RFC, is to do certificate-based authentication between the logging source and your log collector. There's a number of problems with this, though. RFC 5101, which dictates how IPFix, which is basically the modern version of NetFlow, it allows for a TLS transport, but I have never seen anything, not one network device that is able to generate IPFix over TLS. It's always over UDP. You do have client-server overhead, and depending on how the network's configured, if your log collector goes down, bad things can happen on the network, and that shuts the project down in general, right? You can also have reflection, denial of service, when you try to connect on a TCP handshake, something's trying to connect, and all the packets can't connect, and you're having issues inside the network. The second thing you can do is IP spoofing protection. We'll talk about some ways of doing this. Just with UDP packets, you can lie very easily. There's no handshake. I can say my source IP is whatever I want, and as long as the network will route that packet, there's no send to come back. There's no verification of paths. So there are some features inside of network switching. That's the command for Cisco iOS on reverse path. And what this does is it tells the networking switch to verify that the thing sending you the data actually is the thing, that it owns the IP address. It's also checking the MAC addresses. You can spoof MAC addresses as well. There are some emerging technologies like microsegmentation that can help in this by putting, by controlling the flow of information around networks. TrustSec from Cisco is another theoretical answer for controlling how data moves into your security segment. You do want to tightly control access to the security logging infrastructure. So it needs to be on its own network. You need to monitor closely how data comes into it, how data goes out of it. Honeypots are a great way for a fallback. Potentially, if you're under attack and some of these attacks we're going to see are generating recon activity from everything on mass implication. The cool thing about honeypots is they're generally a zero, and by themselves, a zero false positive type of scenario, that you shouldn't be connecting to something that doesn't exist. If you're doing that, there's something wrong with you. So it's a great way to fall back and know here's an attacker because the attacker is connected to a non-existent device. And then this one's really key, is as you're collecting logs, you're tagging how it was collected. What was the IP address reported? What port did I receive it on? What machine received this message? And holding sort of a chain of custody on the flow of that data. All right, so the attacks we're going to go over aren't going to get you initial access, so this assumes you're already in, but everything else works. So my favorite thing is the pump and dump. And the way this works is generally I use Docker containers. So I spin up a Docker container. I do I spoof the MAC address in the container. I'll show you how to do that in a second. I put my own IP address. I do whatever the hell I want to do, scan the network, steal data, run some attacks, whatever I want to do for a period of time. For me, that's generally about 3 minutes. And then I destroy the Docker container, spin up a new one with a new MAC address, a new IP address, and do it again. And so that makes it very difficult for the security operations team to find me, what machine I'm actually on, because they can't track me by MAC. And if they don't have the MAC, they can't find the access port that I'm on, and so forth. And if you can physically move, that's even better. So that's a pump and dump, which I'll show you. So to do it, the top thing is does this work? Yeah, this is the Docker command. This pulls a Kali Linux Docker image from the Docker Hub, generates a net new network with this fake MAC address and spins it up. And in this case, this machine would get a DHCP address against that MAC address. So that's really helpful if you don't understand the network topology yet. Grab a DHCP, drop the MAC address. The DHCP server will issue a new address to the new MAC address. And then you just kill it. and just kill it right here and start again. Pocket dimension. This is really cool. So this is basically creating a fake network on your computer to do fake things. It's sort of like a shadow campaign where you're whispering lies and someone else reports the lies to your SIM or your analytics tool. So you can create a network that's on it could be a /0 if you do a little bit of working, but it could be the whole internet. And then you spin up Docker containers and assign them IP addresses of anything you want. You can assign them for the internal domain controllers. You can assign them for AWS machines. You can create any machine in the world in this fake scenario. And then you can do things to these fake machines. So I can scan the entire internet in this fake world. I can stage information. And this is really good for baseline boiling because you don't have to actually move the data in the real world. You move the data in the fake Docker world. And plugging that into an access switch, it's going to generate NetFlow records referencing your fake traffic. And it's going to look real to the access switch. So to like a Cisco 3850. So that's how it works. That's how you do it. You create a network bridge in Docker. It's basically going to bridge the physical interface on your machine that's connected to the network you're attacking. You're going to, in this case, I created a machine with an external IP of 4.2.3.1 and internal 10.10.10.1. Start them both up, and then you have shell access to do whatever you want to do, which is generally going to be whatever absurd thing you want the security team to believe is real. So tell your lie, and then create your lie, and then the network will report it as fact. Log spoofing is the easiest. This is the lowest tech thing. You just send a log. The downside of this is you have to find where to send a log to. And I have a couple of techniques for figuring this out. But doing some DNS checks generally will help on people. Just try like log.acme.corp, and it probably will end up at a logging server or something like that. People are very smart in these things. They help you out. And then you just send artificial records. So let me show you how to send artificial records. And of course, when you're doing this, pump and dump. Very simple to send syslog. Syslog is the stupidest possible protocol. You can use netcat. So echo whatever message you want into netcat to normally port 514 on the target, and it will believe that thing just happened. You can tell it anything you want. It can be in any format. Boom. Any lie you want to tell, as long as you know where to send it. So I'm going to run you through a scenario. I was going to do this live today, but after we couldn't get the projector to work, I figured that the GrrCON gods were not going to suffer me a live demo. So this is 4 records from a real attack. Okay, I'm on 10.10.10.10 and I'm doing crap, right? So I have these 4 records that have been generated from the real things saying that I'm doing something. So clear picture, I'm the guy in the middle, these are the things associated with me. Straightforward, sock and roll with this pretty easily. Got to get 10.10.10.10 off the network, got to talk to John Doe, he's transferring information to 1.5. So if you go to Twitter, I'm at Charles Herring. I've got this on Pastebin. You can grab this code if you want to run it. But let me run you through it if you can see it. So the first thing here is just building out some timestamps, because vendors don't ever agree how a timestamp should look. So I had to build 3 different timestamps for 4 different vendors here. This is the SIM or whatever logging source I want to send this to. I'm going to loop in seconds. So in this case, I'm looping for a minute. I'm just going to spew as many lies as I can in 60 seconds. You could do this. You could do any loop you want, but this one's there. Then I generate a random IP address for an attacker. So this line here is just 10.something.something.something. And it's going to randomly generate that every loop. And then I'm sending 4 messages, one as in the format of Symantec endpoint protection. The second one is in the format of Cisco ASA firewall logs. The third one is in the format of a FireEye log. And the fourth one, which is I love, is a TrapX log. If you're not familiar with TrapX, it's a solid deception net or a honeypot type of technology. And like I said, honeypots are generally the things that you rely on and you know it's real. And so the SOC's going to have that in their brain. And when they see a fake log coming from the honeypot and they don't go check the original honeypot, they'll totally buy into that lie. So that generates it. When I execute that command, it runs. In 1 minute, I generated 46, almost 47,000 fake records, referencing 11,000 fake IP addresses. So it's 11,000 things the SOC has to go track down that's doing the exact same thing that I am. And so now that simple graph looks like this. These are the things implicated. These are all of the attackers that are referenced in those fake records now. And this is just the first 100 records. If we blew this out, this would be an explosion of investigations that you would have to go through, because in that case, there's 11,000 attacking hosts on the network doing bad behavior. So talking about the non-repudiation, some of the things that we currently track are the sender host. So where did the record come from? And this is another important thing to track in all of your logging systems, no matter what you're doing. You can do this in Elastic or anything else. Is how did you get the record? What was the first point it entered the system? So mentioned earlier, to spoof a log, you got to know where to send the log to. Well, here's a cool method: send it everywhere. There's a cool project on GitHub called Samplicator. And on Samplicator, you can say, listen on port 514, and for every message I receive on 514, send it to this very, very, very long list of destinations. So now you send your fake logs to Samplicator. Samplicator sends it to every possible host on the network, and then they'll receive it as long as there's not a firewall in the between to stop them. So in that case, you don't know that the message got there, but it is, if you're in a hurry and you got to get out of Dodge, that's a quick way to make that happen. And it's just as simple as Samplicate, where you're sending it, what port, and then the list of destinations. And you can do that in a config file. You can generate pretty quickly. That only works for UDP though. So if you are taking my advice and you've at least implemented encryption over TLS, it gets a little bit more complicated. But this is a Python script to send that same Symantec message over TLS. So it's just a matter of wrapping it in a TLS wrapper and shipping it over. This will work if client authentication is not enabled. So if you're required to have a client cert, I would have to somehow get a certificate, which I shouldn't be able to do, but a lot of folks enable TLS but don't enforce TLS authentication. And so this 10 lines of code will circumvent that. So nprobe is a cool tool for sniffing a NIC and generating NetFlow records. So what you can do there is you can spin up nprobe, have it sniff either your raw NIC or the NIC of your Docker bridge. So in the case of the pocket dimension where you're trying to send, where you're trying to create fake traffic, instead of having the network infrastructure send it, you can send it if you know where to, either using a UDP spray with the Samplicator to send it everywhere, or knowing where the collector is. You install nprobe, you point it to either Samplicator or the collector, you generate your traffic, it's sniffing your network interface and generating NetFlow metrics about that information and forwarding it off. So you do the bad traffic, it sniffs the bad traffic, it generates NetFlow about that bad traffic and sends it on to the monitoring services. As we move out of syslog into the brave new world of REST APIs, this is how to lie to Elasticsearch. You know, it's not unique to Elasticsearch, anything using a REST API. You just post whatever you want, -d into the interface, and you can lie directly into it. Generally with Elasticsearch, you're going to have log stash too. But anyway, if you need to go straight to an API, you're That's a curl command, so nothing complicated there. So with a mass implication for NBAD, particularly if you need to recon, if you want to scan the whole network, this is very similar to what we're showing before, is generate a pocket dimension, have all of, spin up multiple IP addresses in the pocket dimension, have all of them scan the fake network. That will generate NetFlow records, and then you'll have the same thing. You'll have every machine on the network guilty of scanning the network, right? So this is which one's this one? I forgot this one. Hope it's not important. Oh, I know what this is. Okay, so you're scanning the network and you're getting SYNs and no SYN-ACKs. If you scan those same machines inside the fake network and the fake network is generating the SYNs, the SYN-ACKs, and the bidirectional traffic, they're going to generate NetFlow records of that bidirectional traffic, which will make the system think that bidirectional traffic happened in the real world, but it really only happened in the pocket dimension. So do good traffic in the pocket dimension, bad traffic on the network, it will merge in and become good traffic in the security monitoring because it looks like bidirectional traffic happened. And then we talked about this earlier. This is baseline boiling. This is just creating more and more packets each day. So slowly raising it up. The thing that can be complicated here is you need to understand if the systems are baselining against a set, so all manufacturing workers, or is it each user? Normally it's going to be set-based logic, so you don't have to understand, you don't need to know every user. But even if you, or every host even, but you can just generate metrics on everything. Just generate a little bit, maybe a meg of traffic on network behavioral stuff on day 1, and then a meg and a half on day 2, and that's going to get added on to the existing baselines. And then each day just continue to increase that, and essentially will render all of the baselines useless. So a couple of attacks for that would be geographic. So generating fake logs of logins, make more logins happen than are really happening, successful logins, so that it looks like the traffic or the volume of logins are greater. And then diversify where they're logging in from, and just slowly start bringing that up. You could also use this as an attack if you want to violate the baselines by having violations of every user. Every user just did a magic carpet. So every user logged in from every country in the world. And so that'd just be a matter of generating that metric. So just to recap, and we'll have some questions. TLS, when you can do it. IP spoofing. Segment your security architecture into something that limits the ability to get bad data in there, using ACLs and so forth. Honeypots as a backup, and then chain of custody. You can grab the download either at the blog, my Twitter thing, and then if you go to Twitter at Charles Herring, you can grab the paste bin for the script if you want to play around with the script, but the deck does have all of the code in it. Does anyone have any questions? That's cool to be recorded? You may now clap.